As Introduction to Music Production Assignment 4, I'm going to demonstrate the effective use of a noise gate using a stereo recording of a piano track on a new song I'm writing at the moment. So I've recorded the track in Pro Tools and I'll just play the beginning of it. And it might not be so audible to you there, but in the recording there's a lot of noise. It's the sound of my feet tapping on the floor, clothes rustling, and ambient noise from inside and outside the home studio. So I'm going to use an expander gate which reduces the level of input signal when the envelope goes above the threshold. Now when we think of an envelope, we can think of a tack, think of this diagram here where we've got volume represented on the vertical axis and time on the horizontal axis. So this would be like a portion of sound. So the attack is the initial fast transient, then that'll decay and it'll lengthen for some amount of time and then it'll be released. So we can kind of control this shape as well within our noise gate. And what we want to do is we want to first of all put in a noise meter here to get rid of him. We want to put in a noise gate just to see where the noise actually is, which should be here, noise meter. So we'll just play that again. And you can see there that it's about minus 30 to minus 40 dB. So let's just add an expander gate instead. Okay, so we'll go to dynamics and we'll go down to the expander gate. And we will play this again. Now the gate is at a default setting there, so what we want to do is we want to bring down the ratio to 1:1, which means it won't be working at all. So the ratio is, you work that out, the first number is what's coming in and the second one is what's coming out. So if you have 1:1, it means whatever is going in is also going out. And then we have the threshold. And the threshold, because in the noise meter it's set around minus 35, and let's bring it to that where the noise should be. So it means something below that won't get through. Let's try it again. Now we can also see that that little circle, when it's being played, shows you where the sound is being made. So when that piano stops playing and there's a bit of a pause and you can hear the noise, you can see that it kind of goes around this area, which is where the threshold is. That's that line on the transfer diagram. Vertically here we have the output and horizontally we have the input. Let's just do that again. So that's the piano around here. And as it stops, it's around this level here and it goes down to here. So that's the bit that we want to get rid of. Okay, so let's just bring the ratio a bit up and see if that has any kind of effect on it. We don't want to bring it up too much. 2:1 means that half the signal going in will be coming out. Now that has a kind of a nasty on-off kind of effect. So we might just want to reduce the attack. That means it's going to happen faster. We can lengthen the attack, in fact. It'll make a softer knee. That's 20 might be a bit too much. Let's see. Okay, it's taking longer for the gate to work because the attack is set at for longer. Release, I think, is okay. Let's just leave it at that and hold. Yeah, and we can also see our GOR, which is our gain reduction, and our meter, and that shows you how much of the device is actually working. So let's just see how much the device is working from this meter. So it's kind of it's working when there's a pause in the music. So in conclusion, I don't think that gain reduction is the ideal solution for getting rid of noise on this piece of music because the piano part is quite continuous. This is only the introduction that's not continuous. And there are a few pauses in between the attacks for the gate to really take effect. We're also losing some of the favourable transients that the sustain of an acoustic instrument gives us. So I think a gate in the traditional snare drum or electric guitar is a better use of the two. And thank you for listening to my presentation.